Lensing argument. So I was looking at the Wikipedia, and it's just basically saying like, yes, you have here Wikipedia. Um, and I just kind of got it in a way like how Eddington had basically, so Eddington had basically like, I guess, after Einstein had came out with general relativity, Eddington had come out with like this picture of like a real picture of solar eclipse, and he was basically just showing how the rays were moving around the solar eclipse. So basically, the moon is taking up more space than the sun, from the distance the sun is. From Venus to Mercury, the sun, the Earth being the third rock from the sun, basically the moon uh, supersedes the size of the actual sun from its distance. So, from that distance, general relativity had already done the math for why the rays were able to be seen in the picture that Eddington had took, because gravitational lensing was just an argument that was saying basically that um, light was going to move around the moon, that photons were going to travel around the moon. So then you completely destroy the math of the photons moving in a direction or in one constant line. It destroys the photon argument where the photons are moving in one direction from the vortex of the starting point of the sun. So if you think of it as like a vortex, I mean, a centrifugal force is just maybe like is just like saying it's like a vortex or a spiral, but it's going outwards. So a centrifugal force could be like it's spiraling out. So the photons are spiraling out, and right. So now, how do you have how do you basically see um, the photons? Is just that the sun is basically just like a way bigger version of Earth's core. So it's that great that if it is a centrifugal force or or an outwards vortex of photons, which is how I picture the Big Bang, but that force is has a velocity to overcome time, like the way we decipher time, uh, I guess mentally. So it is moving the speed of light with, and then Newton had already applied the inverse square law. I just don't think it was, I just don't know if it was applied to photons. So, yeah, Einstein, Einstein just did the math for the outwards vortex of um he just said the sun was so powerful and all the photons are moving in an outward vortex with the inverse square law applied from the distance between the sun to the moon during a solar eclipse. And then when you hang um or not when you hang, but when you apply his math, Eddington just coined it gravitational lensing, because Einstein was actually, before he was a theoretical physicist, he was a not an optometrist, but cosmoclist, a cosmoclist. So it's, you would just be discussing the cosmos, and that gets into like Galileo and everything. So yeah, and I think Galileo debunked flat Earth. So um, I can see why Einstein was a proponent, a leader in space theory or Earth theory, solar system in general. So yeah, like basically, Einstein came up with like just more things after that, and basically gave science a really bad rap. Gave science a ignorant example, or made science into an ignorant example with his Latin math, his Latin mathematical equations, but I can also see why that would be relative. So yeah, I guess why would he do that? Why would he? I mean, was it because he was German and he was trying to fight the German philosophers? I don't know.